Okay, Unit 2, Lesson 3 is on systems of inequalities. So inequalities is something that should have been done last year in 8th grade. But really quickly we're going to look back on how to graph an inequality. So really, when you're given an inequality like this here, you have x plus y is greater than 0, or greater than or equal to 0. You graph it like a line. So you just think, right, the boundary line, we always call it a boundary line of the inequality, is the line x plus y equals 0. So you're going to graph that. So remember, there's lots of different ways to do it, but the way I choose to do here is I'm going to use the intercepts. So if x is 0, then y is 0. So we have this here. Sorry, just let me dot that in properly, right? And then also we have, if y is 0, then x is 0. So we have the same point again. So 0, 0 is the x and the y intercept. Now to think about this, the slope, remember, the slope is minus a over b, which is minus 1 over 1, which is minus 1. So the slope of this is negative 1. So you go across 1 and up 1, cross 1 and up 1, and so on. And you just draw a line through those points. Now the thing is, what we do here, we look at the type of inequality, right? So we have this here, and it's a full and complete line. Okay, the greater than or equal to means it's full and complete. Okay, because this line is actually a part of the solutions. Any point on this line is a solution as well. And now we have to shade. Which region is it? So which region gives us our solutions? Is it all of this region here? Or is it all of this one here where our solutions are? So we know the answers to this inequality are either above or below that line. And what we can look at, choose a point, a simple point, say above the line, and we know that if that point is a solution, then every point up there is a solution as well. So let's choose the point 1, 1. Okay, so if you put x for 1, y for 1, greater than 0, we're checking that, that's true. So that means that that inequality is correct. So it means that this point 1, 1 is a solution, which means that all the solution points must be in this area. Okay? So it's really as simple as drawing a line and then checking which side the solution points lie on. Now for this one, because we have the strictly less than, if it's strictly less than or strictly greater than, we use a dotted line to show that the line itself is not a part of the solution, but above and below it is. So our boundary line is 2x minus y equals 1. Again, I'm going to substitute 0 for x. If I put 0 for x there, I'm going to get minus y equals 1. So y equals minus 1 is my y-intercept. Now to get my x-intercept, I let y equal to 0. I get 2x equals 1, so x equals a half. Alright? Here are my two intercepts. Y equals 1 dot, x equals a half. I'm going to put it there somewhere in the middle between 0 and 1. It's not going to be the most accurate, but you get what I mean. Now, because of, there's my 2 points, and because of the fact that it's less than or equal to, our line should be dotted. Okay? Okay, so like that, a dotted line. I'm going to do that a little bit better, actually. Just, okay. So it should be something like that. Now, to check which side of my solution is going to be on, I just choose a point on one of the sides. So what I'm going to do is I'm going to go for the point 0. 0 here, 0, 0 is under the line. It's always a good one to choose if you can. Okay? So if I choose, I put 2 times 0 minus 0 is less than 1. And that's true. So that means that all my solution sets are on the same side as the point 0, 0. Okay? Okay, a quick look at this last practice one. Really fast, we're going to go through this one. So y is less than minus 2x. Less than or equal to minus 2x, so that means that my y-intercept is 0. My slope is minus 2, so that means I go down 2 and across 1. So there we go. It's a full and complete line because it's less than or equal to. And now finally, which side is my solution set on? So I'm going to choose the point 1, 1. I'm going to substitute 1 is less than or equal to minus 2 times 1. So 1 is less than or equal to minus 2. Is that true? Is 1 less than or equal to minus 2? No. So that means that the solutions are on the other side. So the solutions are down here. Alright, there you go. That's 3 quick examples of how to graph inequalities. Now we're going to look at graphing a system. Okay. So now we're going to graph 2 different lines, or two different inequalities, and then we're going to find what the solution points are, where the solution set is for 2. So the first one, right, I'm just going to change this. I'm going to write my boundary line, but I'm going to write it as x minus y equals 2. Okay, so I'm not going to write this out, but I'm going to find my 2 intercepts. So what I'm going to do, I'm going to let x equal to 0, so y is minus 2. Then I'm going to let y equal to 0, so x is 2. And this is going to be a full line because it's greater than or equal to, so I'm going to draw it like that. Now I'm going to check which side of that line are my solution points on. So I'm going to check the point 0, 0. So if I let 0 in, I get 0 minus 0. Or sorry, I'm going to substitute into the original inequality. So I'm going to choose 0 is greater than or equal to 0 plus 2. So 0 is greater than or equal to 2. That's incorrect. So that means it's not on the point of 0, 0. It's on the other point, on the other side. Now let's draw the other inequality. So you have 2x plus y equals 4. That's my boundary line. So I'm going to let x equal 0, so y would be 4. And, excuse me, I'll let y equal 0, so x would be 2. Now this is going to be a dotted line. Now again, I'm going to check my solution set for that one. Is it going to be above or below that dotted line? So again, I'm going to choose 0, 0 because it's on one side. So I'm going to have 0 plus 0 is less than 4. That's correct. So it's actually on that side. So I'm going to shade that in black. So it's on this side of the dotted line like that. Now what you're looking for is the area where the 2 shadings intersect. And the area where the 2 shadings intersect is here. So this area here looks a little bit messy, but this area is the solution to the inequality. Okay? So look, I'm not going to go through all of these, but you can basically see, look, you draw x plus y equals minus 3, but you draw it with a full line for the first one. And second one as well, y equals 2 is the boundary line. It's a horizontal line, and greater than, you shade the correct area, and the overlappings is what you're looking for. So I'm not going to do all of these. Right. Can you write a system of inequalities that has no solution area? Explain why this would be with the help of a graph. So essentially, look, the solution of a system of inequalities is where the shadings overlap. So what you want here is for the shadings to not overlap. So for example, if you do something like this, let's keep it very simple. Right? That there in red is the inequality y is greater than or equal to 4. Now if I come down here and draw this one, and I'm just going to do, just actually for the sake of interest, I'm going to do it as a dotted line. And I shade down here. This would be this would be y is less than negative 4. Now if you look, the shadings of those 2 inequalities don't overlap, so it's no solution. Alright? Look at these ones now. These are a bit more interesting too. So what you have to look at is each of the lines that are drawn, and you have to look at how they enclose the space. So if you look at the rectangle, and look at AD, that's the line x equals minus 2, right? And the area that the square is in, the square, or the rectangle, is all this part here, which is where x is greater than minus 2. Okay? So x is greater than or equal to minus 2. That represents this line here. Now if you look at CB, okay, that's the line x equals 3. But we're less than that, okay, because we're going back behind it. X is less than or equal to 3. Now look at AB. AB is the line y equals 1, but the square is comprised of the area above that. Y is greater than or equal to 1. And then we have DC, y is less than or equal to 4. So basically, you're writing the equations of the lines and trying to figure out whether I'm going above or below them to enclose the space. Now to finish a couple of word problems, right? So what I'm going to do here, I'm going to write the two inequalities. Then you're going to graph them and try to interpret the question, okay? I'm not going to spend the whole time going through the question here when we should be able to manage it by ourselves. So it says let x represent the number of hot dogs, packets of hot dogs, and y represent the number of packets of hamburgers. So you're planning a barbecue, you figure that you'll need at least 5 packets of hamburgers and hot dogs. So hot dogs and hamburgers together, at least 5. So the minimum is 5, so 5 or more. Okay? You can spend, there's $1.90 for a packet of hot dogs, $5.20 for a packet of hamburgers, and you have to spend a maximum of 20. So 190 times the number of hot dogs plus 520 the hamburgers, and that should be a maximum of 20, so less than or equal to 20. You can't spend any more than 20. So there's your two inequalities. You work with that, so you're going to graph that, and then you're going to look at the solution area and pick 2 points in the solution area and interpret what they mean. Okay? Finally, the last one, I'm going to let you do this one by yourself. Try and write the system yourself. Okay? Good luck with that.